if it wants to copy something, or if it wants to do some printing work or something. So that is not considered in CPU time. That is IO time. So now when the process is doing IO time, that time it is not using the CPU at all. So if it stays inside the CPU, what will happen? The CPU utilization will get down because it is inside the CPU, but it is not using the CPU. And if it is inside the CPU, it means that other process will not be able to come to the CPU because there is already one process running. So what we do is we take out that process that is there inside the CPU and bring another process so that the throughput of our system is increased, so that our CPU is busy at all times. This is called context switching. When you switch the context, when a process is taken out from the CPU and put it in terminated state, and we bring another process to the CPU. And whenever the process that was in terminated state is again demanding for CPU time when they have completed their IO time, again they'll go to the same queue, and again we'll give them the CPU. So this is how switching works, context switching. So understood?
Yes, sir.
Good. So we'll see in detail in the further discussion. But yeah, this was the overall brief. So yeah, this we can discuss now. So but yeah, before that, I would suggest you guys to take out your notebook and write about, because I just forgot. So write about the booting process that we discussed, and just see whatever is written, write it down, and whatever you understood, just note it down so that after some time, if you remember, if you try to revise, it is easy for you. So whatever BIOS, chip, volatile, CMOS battery, what happens, post test, beep, GUI, and all the things that we discussed, whatever is coming inside your mind, just note it down in your own words, which is understandable by you. So I'll give you 5 minutes till 6:45. Take your time and just note it down. And after that, just let me know in the chat that this booting is done. So I'll switch to this tab so that you can just note it down this also. So yeah, take your time and just write it down.
Sir, can you once again show the whiteboard, sir?
Booting one. Hello. Hello. Do you wanted the booting one or which one? I think that is actually.
Threads corners.
Acha, so this you can write it down. Board is, I think there is nothing in board as such.
Okay, sir. Just for reference, sir. Thank you, sir.
So yeah, noted it down, everybody. Done? Done? Okay. So what is next? Let's see. Yeah, a brief, just a summary. So we'll just go through multi-programming. In multi-programming, what happens is run multiple programs on a single CPU. Multitasking, running multiple task application on single CPU. Multi-threading is again running multiple threads within a single task in a single CPU. Multiprocessing, running multiple processes on multiple CPUs. So yeah, so I think we didn't have discussed about multiprocessing. I don't think so. So we'll just see once. So multiprocessing, what is this is multiprocessing, what happens is there is a CPU now in new CPUs, not in older CPUs. In new CPUs, what happens? There is a concept of cores. So there is a another logical division or differentiation or whatever you can say. There is a logical division of a CPU inside a CPU. Okay, so this and they are divided in cores. The CPU is divided into cores, and this cores can be treated as independent CPUs. These cores can be treated as independent CPUs. So if you guys might have heard about quad core, octa core, hexa core, and dual core. So dual core means two cores, quad core means four cores, octa core means eight cores, hexa means six cores. So this is how we tell. So by this we can say that if it is a quad core, then four processes can run inside a single CPU. This is the CPU. Inside a single CPU, four processes can run at once because there is a division of there is a division of the CPU into four cores. So this is a multi-processing operating system you can tell. Okay, so this was all about multiprocessing. Now resource sharing are shared among programs. Resources are shared among tasks. Share. So this is useless. Nothing to recap. I think we started from here, from the last, from the fourth point. What happens when you turn on the computer? Process means the program is in execution, like the difference between and the discussion. So now we'll see what is next. So this is, I think, ended. This PPT is done. So I'll open up the next PPT. Give me 1 minute. Mhm. Visible now? Yeah. So let's see what is there in this PPT. Yes, kernel and system calls, process and states, process control block, CPU scheduling, various scheduling algorithms, preemptive, non-preemptive, process scheduler, and dispatcher. So what is a kernel? What are the system calls? So kernel is nothing but the heart of an operating system. Now we have studied that we have discussed that our operating system is the heart of our device. Okay, a heart of an electronic device. But the kernel is again the heart of an operating system. Now, what does this kernel do? The kernel is the core component of an operating system, directly interacting with the hardware and managing low-level resources like memory, processors, and device drivers. So, whatever application that you are running, whatever application, let's suppose I'm running this Google Meet. So, this Google Meet is also like this Google Meet is not a separate application. This is running on Chrome. So, Chrome, if you see, Chrome is an application. So, Chrome needs some memory, needs some CPU. So, Chrome directly does not go and ask that I need this or cannot just go and allocate some memory to itself or RAM to itself or CPU to itself. There has to be a centralized management thing or a supervisor you can call who is there to allocate and deallocate stuffs to different processes. So that person or that component is the kernel. So kernel is responsible for all the interactions from all the interactions to the low level resources that are there, memory, processor, and everything. So application, if you see, is interacting with the kernel, and kernel is interacting with the hardware and presenting the hardware to the application. Okay. Now, what is a system call? So system call is nothing but it is a programmatic way of for a computer program to request a service from the kernel of the operating system. So whenever a program wants to get some resources, whenever a program wants some hardware resources, what it does is it asks the kernel that I want this resources. So that asking process, there is a formal name for that asking thing. It is not, it is asking for there is a formal name that is called system call. So a application does system call to the kernel that okay, I need this amount of memory, this amount of storage, or this amount of CPU. System call acts as a bridge between user level program and underlying operating system. So it is a bridge, as we know, it is a bridge between the program that is running in the user level, that like the Chrome or whatever applications that are running in my laptop, and the underlying operating system. So at the end, we want to utilize the resources. So The communication bridge that has got generated is called the system call. How does system call works? Program initiates the system call, so the program executes a specific instruction or function call signaling its request for a kernel service. The first program executes a sort of function so that it is initiating it, and it switches to kernel mode. So when you are using resources, when you are using resources, your program is running in kernel mode. So there are two types of mode: user mode and kernel mode. When you are not using any resources, when you don't want the CPU, you don't want hardware and anything, so that time you will stay in the user mode. As you as you want some memory, as you want some resources, physical resources, you have to switch to kernel mode. So in kernel mode, what happens? You have more what do you call, more responsibility, or you have more things that you can do. In user mode, you cannot do much of the things. So these all things are there. Now whatever system call you did, kernel handles the request, processes it, and talks to the operating system that can we process this request. Because if you see, if you're running a GTA 5 game, that needs a lot of memory, that needs a lot of RAM, that needs a lot of CPU and everything. Now if the kernel gives everything to the game, the GTA 5 game, other things won't be able to run. Your system will get down. So every the kernel and the operating system is in, is in sync that okay, can we actually give it or not? How it is scheduled, the process is created, the GTA 5 process is created, how we will run it, how we will get scheduled it, and how we will run smoothly. So all the things are synced together with the kernel, and when the hardware thing is done, when the process is done with the hardware requirements, it switches back to the user mode. So yeah, guys, understood kernel. What is a kernel? How the system call works, and
Yes, sir.
user mode, kernel mode. Everyone, great. So it's same. I think it is. Just give me a minute. I think again, if you start this is a big topic. Rather, just note it down about user mode and kernel mode, system calls, kernel, and everything, and then we can uh, end this class. Because if you start this process and states, it is a quite long explanation or discussion. So yeah. Just note it down, whatever we studied right now, the kernel and the system calls, and let me know whenever you're done.
So can you share the slides to us, sir?
Guys, done? Written?
Yes, sir.
Everyone? Great. So, whatever we discussed today, like from the booting and the things that we discussed, is there any queries or any questions that you people have to ask or anything that you didn't understand? Anything? No.
Sir, can you share the today's PPT, sir, the last one?
PPT? Yeah, yeah, sure. Mm, yep. No questions as such? Or everything is clear?
Yes, sir.
Okay. Do you guys find operating system interesting? Yes or no?
Sure, sir.
What, sir?
I'm asking, do you guys find operating system to be interesting or not?
Yes, sure, sir. It is interesting subject, sir.
Yes.
Mostly we have already learned these basics, so we don't have much doubts. Maybe
Yeah.
if we go more into the subject, we might get some more doubts, sir.
So it's like, you people might be able to connect the dots that something that your college has taught, something that I'm teaching. So it will be more clarified.
Yes, sir.
So, yep. So I'm sending you the link A109 for the feedback. A109. This is the link and the session ID is A109. Thanks for joining. You can